And now we're going to set up transfer measurement. So what I'll do, I'm going to zero. Of course, we're a little bit too small. Ran out of travel. I'm going to set my indicator close to parallel and 0. Okay, so I've got 0, and now I'm going to run my part. And relative to this 0.514 stack I made, the part is maybe a little bit different. And you can see it depends on how I've flipped this over, and I get more error. And when I check it this way, I get less error. Oops. Get about almost a 0.5 thousandths difference. So check out this video feed if it's hard to see on the TV there. What's nice about this setup is I can set up just one Joe block stack, set my 0, and then if I have a bunch of these parts to check, I can just run it through and run the next one through, run the next one through, run the next one through, rotate it around. But it's a great way to check a lot of parts, and it's a very accurate way to even check just one part, because I'm now using all the accuracy is the difference between this indicator and the stack height. We're no longer involving the height gauge, which I told you is not as accurate as these two pieces. So we're getting rid of the least accurate part of the measurement, which might be zeroing on the bottom of the rock and working our way up and doing a direct measurement that way. So it's a nice way to reduce your potential for error. And I use it all the time. It's one of my go-to methods for working with a height gauge. All right. So next up, we're going to start working with gauge pins again. And I've already told you how much I like gauge pins for measuring holes. And I like them for measuring certain features with the surface plate. Actually, I don't know why I just did that. I'm going to need this for the gauge pin check. What I wanted to do was get rid of the stack. So basically, gauge pins make a great fixture for either resting a part on for a run-out check or for locating a hole and when you want to use a surface plate. Now, we've already talked about the basics of accuracy and applications and hole inspection, so I'm not going to do that again. We're just going to talk about how you can use them on a surface plate. And one of these pins goes into the flange. I think it's this one. It's definitely this one. And I'll show you how we clamp it on. So I can clamp on this pin. The pin has that near perfect accuracy I always talk about. And so does the V block, and so does the surface plate. So when you combine all three, you don't really introduce any new error into the equation. So now I've got a nice clamped V block, just like in the picture here. And you can slide your part on and do your checks. And now you're registered on the ID, which can be useful for many checks. It can make it more balanced. It could also be a datum, in which case now you've slid your datum onto a gauge pin, which will help with your measurement. So one key thing to remember, whether you're doing this in a milled part or on a turned part, checking for run out, your gauge pin's always going to have a little bit of a gap. And when you have that little of a gap, your part is going to rock a tiny bit. So you try to find the largest pin that you have that will fit and minimize that error. A lot of holes are going to be tapered like you see in this picture. So when they're tapered that way, one end is going to be tight and one end might be loose, but realistically it should be within a thousandth or two. You shouldn't have a lot of taper and precision holes. So again, this is another technique I use all the time, and quite happy with it whenever I need to do run out checks or hole locations. So let's do a quick run out and circularity check on the surface plate. So as you can see, I've already got it clamped on, and I can just slide my part on. And first of all, let's check how much wiggle there is. So I'm going to sweep for center like I've always talked about. Oh wow, I'm getting really lucky with my pressure in this video series. All right, so I'm at 0. Let's see how much wiggle there is. There's not a lot of wiggle because I keep twisting it. Not a whole lot of wiggle. So I've got a very tight fit on my pin. And then I can rotate it around, and yeah, you see the pin falling in the hole, but other than that, I took my eye off the gauge. It fell off center. It's very it's pretty consistent. And then I'll do a run out check. I'll flip it around, make it a little easier on me, and do a run out check. Now I'm checking the ID against these surfaces. So I'm doing run out on both surfaces. Indicator's barely moving, tiny bit. So part of that is me knocking the Joe block around, the gauge block, V block. So it's pretty stable, pretty good condition part. And once like I said, both of these are a run out check because I'm registered on the ID and I've got my indicator on other surfaces. And once again, feel free to involve the drop gauge. I won't show it on the secondary camera to save a little time, but feel free to drop this down, set up your stroke on center, and then spin it around. Oh, well, of course it falls in the hole. You will want to be careful that this adds quite a bit of weight. Might throw your part out of balance, but otherwise, oops, fell off. Wasn't paying attention. Well, I was trying to pay attention to the monitor, so not getting any movement on the indicator from what I can see, and I wouldn't expect any. But yeah, feel free to involve your drop gauge. I do this all the time as well. I think I use these two gauges almost the equal amount, and I actually prefer to use a drop gauge as much as I can because of how easy they are to work with and drop up and down, and this is a perfect way to use it. But I probably would use a height gauge as my first choice. If it got larger, it's such a small part, I would probably use the test gauge, but as it got larger and larger, I'd be more inclined to use a drop gauge. Sorry about the technical difficulties. Now, to do a hole location, to do a hole location, we could not use the pin, and we could try to get our indicator inside of a hole and sweep the bottom of the hole and find the bottom of the hole. use our height gauge travel, just like we do with anytime we use the height gauge, but I'm going to show you both ways. I'm going to show you with a pin and without a pin. So let me show you without a pin first. So I'm going to grab, I'm going to get 0 off of the bottom. Once again, I need to adjust my indicator. So I'm going to set 0 on my indicator, 0 and 0 here. Now I'm going to move up and go inside of this hole and then go down. And now what I need to do is I need to sweep the bottom, okay? So my indicator is inside the hole. I think you can see that a little better. And now I'm going to sweep the bottom, looking for that point where it turns around. Okay, it turns around right there. So I'm going to set it there. And now with my pressure, adjust to read 0. Take my reading. 0.309 is what it looks like. And well, how big's the hole, right? We're interested in the center point. If you check out the print for PM02, the angle block, we should be about 1/2 inch to the center point to the bottom of the hole. So how big's the hole? Let's use our gauge pin, figure out how big our hole is. So the largest pin, I already grabbed the largest pin from the set. The largest pin that would go in is a 0.3875. So let's do a little math together. So 0.3875 divided by 2. What does that equal? Oh, man, hold on a sec. You know what? I'm a little cramped on space here, so let me. And I'm trying not to break anything. So 0.3875, divide that by 2, and you get, let's see, 150, 190, 193 and a half. Let's call it 194, round up. So I've rounded up to make the math a little bit easier. And what did I get with my indicator measurement? I got 0.309. So my center point will be 0.503, which is in spec and pretty much what I expected it to be. So that's one way to do it. The other way to do it would be to use that pin I used to figure out how big the hole is and put that into the part. And we can repeat our 0 just to verify everything's still good. Okay, reading 0, and then I can come up and sweep the top. Adjust our pressure. And what am I reading now? I am reading about 0.688. And what I can do is subtract. Let's see, I won't show you on the camera, but you can follow along with your calculator. So 0.688 minus 0.194, get 494. So both are in the ballpark. 0.494 is what I got for the center point. And just because I got very different readings, I'm going to re-verify my zeros. Once again, I'm going through sanity check. Yeah, it looks pretty good. I'm going to flip it around and check the other side. So I'm sweeping for top. Yeah, 0.690. So what does that mean? With one method, I got 0.503. With another method, I got about 0.495. If I take a look at this hole, it's got a lot of chatter in it. And I'll bet if I use a caliper, .310, I'm verifying, sorry, off camera, 0.310. This is the one that I did without the pin. I got 309. And with the pen, with the caliper, I'm getting 310. But with the pin, I'm getting a much different reading. And that tells me even though this is the largest pin that goes in there, there's a little bit of play, which makes me think the hole is not round because of all the chatter I saw.